Hi guys, we're gonna compare linear solvers today. Yay! There's two pieces of software. One is Intel Math kernel library Pardiso solver. It's part of the Intel Parallel Studio. The other one is a separate project with the same name, originally developed by the same authors, but now it's a different standalone library from Paridso-project.org. Now I created a benchmark which I'm gonna run right now. It loads binary files that store sparse linear systems and essentially crunches that linear system to obtain the result. The original matrices that I have, they are stored in block compressed sparse row format. It's a sparse matrix, but in the block format each entry is a submatrix, the one that I have a 3x3. Apparently, if you have that structure, you can use it to optimize things. So that's the original format, the number of non-zero blocks, and the size of the matrix in blocks. It's a square matrix. And then the other version of it is when I convert the block sparse row to a normal sparse compressed sparse row format. That makes it 2 million non-zero entries and 90,000 elements in size. The other values here, it's a time in milliseconds that takes for the CSR system to be solved and the block compressed sparse row system to be solved. The timings are similar, but the block format is slightly more optimal, so it takes faster to solve it. Now, while it's running, I'll show you real quick when I got those matrices from. This is from my PhD project in ice mechanics. It's mostly dynamic nonlinear finite element method that leads me to solving these systems. And this is the type of it's a diagram that explains the compressed sparse row format. If you're not familiar with the sparse matrices or formats, there is an awesome Wikipedia page that describes how they look like, and they find a lot of applications. For example, here in the page for Pardiso, they utilize it for testing, of course, but they take the examples from electrical circuitry. And what they claim is that the Pardiso 6 solver is significantly better than Intel MKL by a factor of 5 in this case, by a factor of 6 in this case. I'm looking at 8-thread machine here. Now my computer is a very weak laptop. It's a mobile processor, i7-8565U. It has 4 cores, 8 threads, but it's not very fast, and it's not well cooled because it's inside a computer case. Now let's take a look at the results. They're not done yet, but we're still waiting. There's quite a lot of matrices. Some things, for this project I had to create 2 separate executables because I couldn't share the libraries because of the same function name. Strangely enough, not only these functions perform differently, but they are also quite different in the way they're used. There is a number of parameters, and in fact among those there is one iparm, which is actually an array of 64 more parameters that are configuration for the Pardiso. So both functions have that, but the layout for that iparam, for those 64 parameter array, is different in MKL implementation and in this Pardiso implementation. And there's some functionalities that are different. So they're not exactly interchangeable. Alright, so we got the result from the Intel MKL. 121 seconds for the more general CSR format and 110 seconds for the block format. Now those are saved into a file, and at this time I'm gonna run the Pardiso test, the other library. Now, as they claim, it should be several times faster. We're gonna see real soon whether it's faster or slower. For now, I will speed up this portion of the video because it may take a while, and in the end my code will print out the results. And while we're still on it, in the description of the video there will be a link to my computer code and all the matrix files in case if you want to try to reproduce this. The code is not huge. It's basically a small loop. It loads up the matrices one by one, creates a CSR version of it, and executes the solver, keeping track of the time. For MKL, it tries two options, the CSR and block CSR. For the Pardiso, it only has one option because it doesn't have the block option there. In the end, it will print out the time in seconds that took to process all the matrices. So right now what we're gonna do is just wait until it comes to completion. It took 844 seconds to solve the same number of matrices, linear systems, in Paridso-project. What a disappointment! Unfortunately, I will not be using this library. It is about 8 times slower in comparison with Intel Math Kernel Library. Well, that's it. Thank you for watching, and check out the code in the description.